All right, we're going to go ahead and get started. Thank you so much for joining us today for our public sector webinar series. Today, we're going to be talking about confined space hazard awareness. One thing to note is this is a very broad topic. We'll talk about the fact that there are actually two standards on this when we're thinking about OSHA that we consider most frequently, which is construction and general industry. So today is really just a highlight reel of making ourselves aware of what types of confined spaces there are, if they require a permit or not, and really diving into some examples as well. And joining me today for our webinar will be Andrew Kowski from our team here at the Wisconsin State Laboratory of Hygiene's WisCon team. So we're going to go ahead and get started. So today we're going to be covering a variety of topics. Again, this is going to include general requirements for confined spaces, understanding a little bit that general industry does vary from construction, what a confined space is and associated definitions that we'll see, and then the types of confined spaces that there are. So non-permit, permit required, and then classification, if a classification changes within a space, as well as rescue and going through some examples. So one of the things that employers are responsible for is evaluating their work sites for confined spaces. And after they've identified if those confined spaces exist, we need to label those spaces to let employees know that they are there. Additionally, we need to train those same employees on the hazards that are associated with confined spaces, such as not entering those spaces. There's additional training for employees who are allowed to go into those spaces, and we'll talk a little bit about that as well. So what are the standards that we see when it comes to confined space? So the first one is going to be general industry. So this is 1910-146. And this is focused on permit required confined spaces. You can see that on OSHA's website. There's also a separate standard for construction. And this is going to be 1926 subpart AA for confined spaces in construction. Each of these contain requirements for practices and procedures that are established to protect employees who must enter those confined spaces. But this really ensures that employees recognize what a confined space is, when it's okay to enter, and what needs to be done before they can go into those spaces safely. Moving into some definitions. So what is a confined space? So the three major elements that we're looking at in defining confined space is one, is it large enough that an employee can enter and do some sort of work? Does it have limited restricted means for entry or exit? And what we mean by this is, does the worker have to contort their body to enter the space? Do they need to bend or crouch down, crawl, or go on their knees to enter that space? And then one of the other things we think about for that limited means of entry or exit is there kind of like a non-standard entrance or doorway, if you will, in meaning is there a manhole or a hatchway or an inspection port that makes that space only accessible by ladders or rungs or a hoisting device. So some of those can be really good indicators on that restricted means part for entry and exit. The last element that we're looking at for a confined space is that it is not designed for continuous occupancy. So that's kind of the last element we're looking for there. And then the other definition that's important is entry, which means the action by which a person passes through the opening into a permit required confined space. And this occurs as soon as any part of the entrance body breaks the plane of an opening into a specific space. Now we're going to dive into the different types of confined space that we see. And the first one that we see is a non-permit. And this is a confined space that does not contain, with any respect to a hazardous atmosphere or any atmospheric hazards, or have the potential to contain any hazard capable of causing death or serious physical harm. For these, we do still want to see warning labels or signs that are out there, and we want to have awareness for employees that they should not enter these spaces, but it does not require a specific permit. The next type of space we have is a permit required confined space. And this is one that contains or has the potential to contain one or more of the following characteristics. So these would be spaces that contain or have the potential to contain a hazardous atmosphere. They contain a material that has the potential of engulfing an entrant. So, for example, water, sewage, grain, or soil. We also have internal configurations that might trap or asphyxiate an entrance by inwardly converging walls or floors that slope downward and taper into a smaller cross section. And then we also have the last one, which are any other recognized serious safety hazards. And so these typically are hazards that pose a threat to life or health. They can be electrical hazards, pests, ionizing radiation, impalements, punctures, falls, those sorts of things. But we're going to dive a little bit more into that in just the next few slides. Examples of confined spaces that we often see are going to be things like tanks, vats, sewers, silos, pits, wells, degreasers, tunnels, and hoppers. This is a workflow chart that I think is super helpful when thinking about permit spaces and just kind of working through it. It's a really quick tool. We're not going to spend much time on this because we're going to go into the definitions a little bit more. But if you're looking for something to add in to a written program that you have, is just like a quick check to ask yourself things. This is a really good flow chart to screenshot and save for later. And basically, it just goes through the three questions we ask for. Is it considered a confined space? Yes or no? And then what type of atmosphere does it have? And then, or hazard? And then based off that, is it permit required or non-permit required? This is an example here that we see of signage that we want to use. And so this would be danger, confined space, enter by permit only. And when we're thinking about those permit required confined spaces and what those include or what they contain, what we're looking for there is, do they contain or have the potential to contain that hazardous atmosphere? So some examples of that might be chemical tanks, as well as fruit and vegetable storage areas with altered atmospheres. So these would be atmospheres that are controlled in storage rooms. When we're thinking about atmospheres, we're often thinking about flammable gas, vapor, or mist in excess of 10% of a lower flammable limit. We're also thinking about oxygen deficiency and enrichment, which we'll touch on in a little bit. And then just different atmospheric concentrations of substances above the PEL for acute toxic chemicals specifically, or other atmospheric concentrations that are immediately dangerous to life and health. The next that we consider is engulfment. So does this contain a material that has the potential for engulfing an entrant? And so these are materials that are traditionally drawn from the bottom. So you can think of grain silos as being one of those. We also have liquids or materials that are suddenly released into a space, such as like sewers or storm drains. So that's kind of what we're looking for there. But traditionally, this is where we see individuals who could be aspirated to death by having that sudden filling or plugging of the respiratory system. If you have that grain coming down, or that the substances or different hazards could exert force on the body to cause death by strangulation, constriction, or crushing when we have that engulfing situation. Next is our configuration hazard. So this has the internal configuration such that an entrant would be trapped or asphyxiated by inward converging walls or by a floor that slopes downward and tapers into a smaller cross section. So traditionally where we're going to see this is going to be vats, bins, or hoppers. And then the last piece of that is going to be for permit required confined spaces is a space that would contain any other recognized serious safety hazard. So this would be a mixing vat or tank with an auger, fans and cooling towers, potential turbines. We're also thinking of like equipment, so different things that have those machinery or electrical components, falling objects as well. So when we have that permit required confined space, there are elements the employers must adhere by. And so for one of those, it is preventing unauthorized entry into the space. It's also identifying and evaluating the confined space hazards before employees are permitted to enter that space, and developing and implementing the means, procedures, and practices necessary to ensure safe entry, but also safe rescue in the event of an emergency. One of the other things employers must do is provide equipment. So they need to provide testing and monitoring equipment to make sure that those spaces are safe to enter, ventilation, depending what type of space it is, communications, so that individuals who are working in the space can communicate with individuals outside the space. We also need to have personal protective equipment. So depending what you're using when you're going into that space. Maybe it's respiratory protection. We also have lighting, barriers, ladders, rescue and emergency equipment if self-rescue is expected, and then any other type of equipment necessary for safe entry and rescue from that permit space. Additionally, employers must provide at least one attendant outside that permit space. They also need to have procedures if that one attendant will be responsible for multiple spaces. They need to designate a person who they are going to have fulfill active roles, and develop and implement rescue procedures, a written permit system, coordinate entry for multiple employees and employers or contractors, and then they need to develop processes and identify conditions for canceling or entry. So, for instance, if an alarm suddenly goes off, or if, for example, an attendant has to get pulled away, notifying that individual, the entrant, to come out of that space. The other thing that we need to do is evaluate our permit required confined space by performing testing. So we always want to test the various air levels to ensure that the entire space is safe. So we don't want to just dip a monitor in at the top, because the concentrations at the top and the bottom, for example, for oxygen levels or potential gases, can be very different depending on their weight. So a safe atmosphere on top does not always mean that there is a safe atmosphere at the bottom. So that is why we need to have testing equipment to make sure that it's safe to enter those spaces. We also need to make sure that that equipment has been calibrated properly and that it is up to date. We don't want to use equipment that is out of calibration, because it may not accurately represent what that atmosphere traditionally looks like. Additionally, we need testing protocols. So this is including time intervals and how often the space will be tested, especially if it's a long project that's drawn out and the space is changing, or there's multiple contractors or individuals working together in a space. And then two, focusing on the levels and the height of testing. So making sure you're not just testing one part of the space, but you're testing that whole space. And then you also need to review and revise entry procedures and come up with that permit space program. One of the other things to note is that the classification of a space can change. And so this happens when the work being conducted in the confined space changes classification due to the generation of sudden toxic substances. Maybe there is combustion of available oxygen or flammable vapors that do happen to be present. And when we're thinking about those atmospheric changes or conditions, oxygen is one of the ones that we think of most often. And so what we're looking at here is really understanding oxygen enrichment and deficiency. And so what we know is that oxygen deficiency can be caused by a couple things. So work taking place inside that confined space, so combustion. So when we think about that, that is like fire, maybe welding, clothing, internal combustion engines that can consume some of the oxygen, making it an oxygen deficient environment. You can also have decomposition of organic matter. And then you can also have situations where there's displacement by a heavy gas that's settled into that lower lying space or by another vapor, like an inert gas. Where we have oxygen enrichment, we also have situations where we have more than 23.5% oxygen. And what happens in those conditions is that it is an extreme fire hazard. For that, we're really worried about when there's that static electricity for materials. This could be things like hair or clothing, and they can provide an ignition source that's needed to start a fire. And so this scale is really representing just what happens when we have low levels of oxygen, or that oxygen deficient environment versus that oxygen enriched environment. And so that's one of the things we're monitoring for when we're monitoring that confined space, is to determine the oxygen that's present. For entry, you need 19.5% oxygen is the minimum for safe entry. We really want to see about 21% is normal. But as you can see on the scale, is less oxygen is in that environment, that's where we have that impaired judgment and breathing. There's often rapid fatigue or passing out, and then even death is possible. The other thing we're concerned about or watching is for those atmospheric conditions is going to be the flammable vapors. So what we're thinking about here is hot work, for example, so welding and cutting, what equipment is being brought into that space. And so when we're thinking about gas and air mixtures, we have kind of two things we're looking at. So we're looking at the LEL, or the lower explosive limit. And this is looking at the lowest atmospheric concentration of fuel in the fuel air mixture at which a gas or vapor could potentially explode. And then we have the UEL, or that upper explosive limit, and that is the highest concentration or atmospheric concentration of a gas or vapor in the fuel air mixture that can explode. And again, that's called the UEL. So we really want to make sure that we are having either a lean space or a rich space, but we don't want to be in that middle where we have that flammable mixture that can occur if there's too much or that perfect combination of gas and air. Next, I'm going to pass it off to Anne, and she's going to talk a little bit more about confined spaces and confined space rescue and what to really be aware of and some examples.
All right, thank you, Kelly. I guess we could take a break too. Does anybody have any questions? You can raise your hand or put it in the chat if you have a question. Okay, I'm not seeing anything, so I want to go on. So one of the reasons confined spaces can be so deadly is because would-be rescuers end up becoming victims. Frequently, a person's initial response to seeing somebody drop in a confined space is to go and get them. And usually that results in the would-be rescuer then becoming the victim, as I previously said. So I wanted to talk about some aspects of rescue. So next slide, please. So when you're thinking about getting or having a rescue service, you want to make sure that the rescue service that you're going to use can get to you in time. And this is a visual of a grain elevator engulfment. And as you can see, it takes 25 seconds for someone to be totally engulfed and later asphyxiated by this grain. So depending on what your confined space hazards are, you're going to want to understand how quickly the emergency and rescue team can respond. And you also have to take into consideration that even if there's a response time that is 2 minutes, it's going to take the team time to get things set up, right? Because the team doesn't just jump into that confined space. They usually also have to put on gear. They have to put on retrieval lines. So it's not just arrival time, it's arrival and setup time. So there can be a delay in actually performing the rescue. So you're going to want to keep that in mind. Next slide, please. You also want to make sure that who's ever on the rescue team or performing the service has the equipment needed to provide or to conduct the rescue. So a lot of times there's special equipment that is needed to perform rescues out of certain configurations of confined spaces. And this equipment's very expensive. So if you live in a small town, they may not have the funds to purchase the proper equipment, and they may not have the capability then to provide a rescue out of a confined space at your facility. Also want to make sure that if you are relying on a local service, that the local service knows that you're relying on them. I've encountered situations where the employer's response is that they are going to use the local fire department, but they've never let the local fire department know that that's the employer's expectation. So you're going to want to communicate with the service that you intend on using, and you also, according to the standard, have to give the service access to your facility so the service can train and understand the confined spaces that are at your work site. And it's also good to do this on a periodic basis because a lot of fire departments are going through a lot of personnel changes with retirements and adding and budgets. So you really want to make sure that if you're using your local fire department, that you're bringing them in on a routine basis so that they can practice at your site and they understand the hazards, the confined space hazards that are present at your site. Also want to make sure that if you are relying on the local fire department, that you have a backup plan, because the local fire department responds to other clients, right? So it may be that they are not available to respond to your confined space hazard because they're out fighting a fire. So that's something that that's really important and you're going to need to plan on. So I want to go over some examples of confined spaces. And I just kind of want to remind people that there's confined spaces and then there's permit confined spaces. So crawl spaces meet the definition of a confined space, but they're generally not permit required confined spaces unless someone is going into that confined space because there's a broken sewer line or there's something else going on, or perhaps there's work going on in the crawl space where there's live electrical, then it becomes a permit required confined space. Also, attics. Attics are technically a confined space, but they tend not to be a permit required confined space. However, if it's a large attic and there's other crews working in there, and perhaps someone's spraying a chemical, or that it's the summertime and it's extremely hot, there could be some other issues, some other, conditions of that attic space that may turn it into a permit required confined space. So one of the concepts of the confined space standard, right, is to help people understand that there's confined spaces and that sometimes depending on what's being done in that confined space, it can become a permit required confined space. So the work inside can make that space become a hazard. Some dock levelers are considered confined spaces, and this throws a lot of people off because when you look at a dock leveler, you don't necessarily think that it's a confined space, but what the hazard here tends to be is a crushing hazard. So if this dock leveler is not locked out correctly when someone's working on it, they can get crushed by them. And lockout tagout tends to go hand in hand with confined space quite often. So quite often when you see a confined space fatality or injury, frequently there's a lockout tagout issue associated with it too. So you're going to want to keep that in mind. So here's another example, and this is a weigh tank, and it's actually laying on its side. At the time of the incident, it was sitting upright. So this is an 8,000 12 by 12 foot weigh tank. And it contained a little bit of liquid whey when they entered that worker in through that 16-inch diameter hole that is technically at the top of the tank, but right now you're looking at the side. It's kind of where that white and black matter is hanging out. So what happens is that whey produces carbon dioxide gas as it decomposes, and it was actually a hot day. And so rapidly generated a hazardous atmosphere. The worker who was in the tank wasn't directly visible, And so it took a few minutes for someone to figure out that they had passed out in the tank. And what had happened was the fire department was called. And what the fire department did was they put this tank on its side, and the hole you see cut in the side of the tank is what they used to retrieve the worker's body. Some other examples of confined spaces that you won't necessarily associate are water features. So you see fountains, you see these sometimes in swimming pools, but what it is that the control valves for these water features frequently are located in pits, and there tend to be low oxygen levels in those pits and or high carbon monoxide levels. So you want to make sure that even though, it doesn't seem like a big space, it can also have a hazard. And once again, the minute a body part breaks the plane of that confined space is considered entry. And unfortunately, what happens is that people will put their face in the confined space. And if there's an extremely low oxygen level or some other extreme atmospheric condition, that person sometimes immediately falls. And that's what becomes the issue, is then they fall with their body or their head inside that confined space. Another confined space is pits, right? And a lot of times these pits, people will go in them to open or close valves, or they're installing or upgrading a pump, or putting in electrical or cable boxes. Some of them are completely underground. Some of them are below grade. And a lot of times, if you have the opportunity to redesign something where someone has to go into a pit like this to routinely turn a valve, it's good to try to design it so that you can control the valves either remotely or above ground. So I've seen in a couple wastewater treatment plants where when they've redesigned them or upgraded them, they've changed it so that they can control the valves without going into a confined space. So that's always something to keep in mind if you have that opportunity. You'd like to design out the confined space hazard. Some other confined space examples are pesticides and spray tanks. So, right, any tank used for storing, mixing, loading, or spraying a pesticide or fertilizer, it can be a confined space that's entered. And sometimes this photo on the lower left is what I was talking about. People will put their face in there to look, and that's when sometimes they'll fall in or they'll partially fall in. And another issue is for this larger photo, kind of toward the right, what they've done is they've cut away the side of the tanks. You can see that there's agitators and other things that can grab people's clothes or body parts and pull them into the tank and cause a hazard. So sometimes it's not just the atmospheric hazard, it can be a mechanical hazard that either severs a body part or pulls you into it and crushes you. Another example is garbage trucks, and this is one where it's a lockout tagout, and it's a crushing issue. So you normally wouldn't consider a garbage truck a confined space, but if it's not locked out, and frequently people will go in there, or the employees will go in there to clear a jam, and something happens and it gets activated and they get crushed by moving parts. All right, so for a summary, we'd like to go over that you need to evaluate all the spaces in your work, and you need to train all workers, right? Everybody needs to be aware that you have confined spaces in your facility and what those confined spaces are and whether or not they're permit required confined spaces. Also, if you do have employees who enter confined spaces, there's a lot more extensive training that they need to go through. At the end, we have some links. There is a lot available online from a lot of state OSHAs and OSHA itself, so you can use those for online training. Also, you need to make sure that workers review, understand, and follow confined space procedure. It's not uncommon where someone thinks they can just pop down into that pit and fix that issue really quickly, and that can become a confined space fatality. You also have to have an emergency emergency action plan. You gotta have it written down, and people need to understand what happens if an emergency occurs. You need to have that written confined space entry system. And also, when you're doing work inside the confined space, you really need to consider what's going on. Are there chemical reactions with what's happening in the space? Are you generating some type of hazardous atmosphere because you're in there? And what other work is going to be performed inside that confined space if there's more than one crew working in it? All right, Kelly, back to you.
So the next piece that we're going to do is review a case study that was published by OSHA's Fatal Facts. And this is focusing on a confined space fire that resulted in two fatalities. And so we're just going to kind of walk through the situation, what happened, what could have been done differently, and things that could be done moving forward. And so in this specific case, there were two contract crews working on the inner walls of a connected pair of pulp bleaching towers in a paper mill. One crew was installing a new fiber reinforced plastic. The other crew was working in a separate tower, and they were focusing on sandblasting to remove different debris to prep for this new fiber reinforced plastic to be installed. The two different towers were connected through a very tiny tunnel, but they were separate towers, so the groups were working independently in the two towers. The installation crew was using a flammable resin to install that fiber reinforced plastic sheets, and they were doing this because of it being cold and the resin was not curing properly. So they decided that they wanted to use a heat gun to warm this resin in this space to help cure it. What ended up happening is that this heat gun fell into a resin bucket and ended up igniting that resin material. When that happened, the crew that was installing that fiber was able to evacuate the tower. But we do know that those towers were not isolated, and the fire ended up spreading through a crossover pipe into that other tower where the sandblasting was being conducted. The two who were doing the sandblasting operations were unable to evacuate, and they ended up dying from smoke inhalation and multiple blunt force trauma due to scaffolding collapsing on top of them due to that fire. Violations or actions that contributed to the workers' deaths in this situation was that there was no communication between the two subcontractors that were there to do concurrent work activities. There were additionally no planned changes. There was a failure to use available cold work options for that resin process as well. When it comes to hot work deficiencies, there was a failure to recognize that heat gun as an ignition source and a failure to request a hot work permit for its use near those flammable vapors of that resin. And the use of that ignition source, again, that hot heat gun near that flammable liquid. Additionally, a fire extinguisher was not immediately available during the hot work. At one point, if you do end up reading this case study, they tried to use the top of the bucket from the resin, which just ignited and melted, causing that fire to spread. So again, having that hot work elements all configured would have been super beneficial. Other confined space deficiencies were failure to identify hazards within the confined space, such as the use of that flammable resin and that combustible material that was being used, or the fire hazard introduced by the use of that heat gun. Additionally, there was failure to complete required sections of the confined space entry permit, including adding a designated entry supervisor. Rescue personnel could not respond in a timely manner, and there was no continuous forced air ventilation while work was being performed in that confined space. Additionally, there was a failure to recognize that the pair of towers as an interconnected unit and coordinate and communicate concurrent operations between the different subcontractor crews that were working. If you want to read more about this case study, again, in the presentation, we have a variety of links, but these are not unique circumstances, as Anne mentioned earlier in the presentation. About 60% or two-thirds of fatalities for confined space also come from would-be rescuers. So again, working through emergency situations, having plans and backup plans is super important when we're talking about how to avoid increasing the number of fatalities in confined spaces. Some resources that are out there, you can always go to OSHA's website. They have a lot of different information about confined spaces for general industry as well as confined spaces for construction. There's also a small entity compliance guide when it comes to confined spaces that can be used. There are also organize or other resources from other states that are state plans for OSHA. For example, Oregon has a lot of resources, for example, not things that are not designed to be occupied for confined space. Again, this is really to highlight an overall awareness. This is not an in-depth training. Confined space training or permit required confined space training can take, on average, 8 hours to go through and fully comprehend and understand the requirements. What our team is able to do and offer is if you are an organization or a small business or public sector entity who has additional questions about confined spaces and if it is permit required or not, you can always reach out to our team here at the State Lab of Hygiene, WisCon, for free assistance. We're able to help answer some of those more specific questions. And kind of really walk you through what you need to be successful if you have those permit required confined spaces, or if you have a question about, is this a permit required confined space or not? We're really here to be a tool to help you. Again, we are a free resource, and we really just want to help support you make your workplace as safe and as helpful as it can be for you and your employees. So always feel free to reach out to us with additional questions. We also can provide training and education opportunities if we're able to come out and do a site visit and evaluate those spaces. We can also help you with some training elements and basic education too for these types of confined space awareness questions. As always, thank you so much for joining us. Our next webinar will be October 29th at 11 a.m., and that will be focusing on work-related asthma. We're going to open it up for questions. So if you do have questions, please drop them in the Q&A feature, and we'll work on answering them. If you have other questions, feel free to reach out to our team. You can send the questions I'll post in the webinar chat. We'll do public sector consulting at slh.wisc.edu. So I just dropped that in. You can also send other questions to WisCon at slh.wisc.edu as well. And we're happy to take those questions. You can go and request services on our webpage if you would like us to come out and perform a site visit. Again, we're really here to support you in some of those pieces. And it looks like there's one question from Colleen, and how can we access the PowerPoint and presentation? We will be uploading this to our YouTube page. One of our team members works on some of the audio and different features, making it accessible. So it's about a 2-week to 3-week turnaround time for him. But we have everyone's emails for those who attended the presentation today. So once we have that up, we'll be happy to send out an email letting you know the link to the YouTube page of where you can find the PowerPoint and information. And we'll hang on for a little bit. So if you do have questions, again, feel free to drop them in the Q&A. Again, thank you for all who joined us. And if you develop any other questions, again, our emails are in the chat if you want to submit questions that way.